What if I told you that a strange, faint object floating 50 light-years away just helped us crack a mystery about Jupiter and Saturn? This so-called accident may finally explain why silicon, one of the most common elements in the universe, seems to vanish from gas giant atmospheres, and the answer could even guide the search for habitable exoplanets. Hi everyone, I'm Naim. Today, we're exploring NASA's latest study using the James Webb Space Telescope. It focuses on a cosmic oddball discovered by chance, a brown dwarf called the accident. This happy accident is revealing secrets about Jupiter, Saturn, and the chemistry of giant planets across the universe. In 2020, a citizen scientist working on NASA's Backyard Worlds Planet 9 project spotted a faint moving dot in old WISE telescope data. Astronomers called it the accident, because it slipped past normal detection methods. It turned out to be a brown dwarf. Bigger than a planet, smaller than a star. No nuclear fusion in its core, just a cooling ball of gas. But the accident was weirder than most. It had traits of both very young and very old brown dwarfs, making it tough to classify. Here's the puzzle. Silicon is everywhere in the universe, yet in the atmospheres of Jupiter, Saturn, and many exoplanets, it's strangely absent. Scientists suspected silicon binds with oxygen to form oxides like quartz that sink deep into cloud layers. On hot gas giants, these can act like dust storms. On cooler planets like Jupiter, they sink so far that spacecraft can't detect them. So maybe lighter silicon compounds like silane, SiH4, should float higher up. But until now, no one had found them. When Webb studied the accident, astronomers found spectral fingerprints of something strange. After careful analysis, it turned out to be silane, the missing silicon molecule. This was huge. It's the first confirmed detection of silane in any brown dwarf or gas giant-like atmosphere. Why here and not on Jupiter or Saturn? The answer: oxygen, or the lack of it. The accident is ancient, 10 to 12 billion years old. It formed when the universe had very little oxygen compared to today. With less oxygen to bond with, silicon paired with hydrogen instead, forming silane. So what does this mean for our own gas giants? It suggests that on modern planets, oxygen is so abundant that it hogs almost all the silicon, burying it deep in oxide clouds. That's why spacecraft at Jupiter and Saturn don't see silane. But the accident shows what happens in a low-oxygen environment. It gives us a window into what Jupiter and Saturn might have looked like if they'd formed earlier in cosmic history, under different chemical conditions. Brown dwarfs like the accident are easier to study than exoplanets because they don't have a parent star drowning out their light. But the lessons we learn apply directly to alien worlds. One day, when we're analyzing rocky Earth-like exoplanets, scientists will face confusing, contradictory data too. If we can untangle the chemistry of a bizarre brown dwarf, we'll be better prepared to parse the atmospheres of potentially habitable planets. As researcher Jackie Faherty put it, sometimes it's the extreme objects that help us understand the average ones. So what do you think? Could studying oddballs like the accident really help us one day identify life on distant planets? Let me know in the comments. Don't forget to like, subscribe, and stay tuned for more stories of how the cosmos continues to surprise us.